Well, good morning, good afternoon, good evening, whenever you might be watching this live Q&A. Good to be back. Sorry I missed last Friday. Had an event up in the mountains that I needed to be a part of. I had a great time. It's actually some fun. So I appreciate you letting me go do that, spend some time with the guys up there. So glad to have you again today. We're going to talk about or answer questions from our last two podcasts. One was on test data management, where we were fortunate enough to have Irene Ford and Kevin Corbett join us for a very interesting conversation around test data management. We'll talk a little bit about that, hopefully answer some questions you might have in that regard. And then last we talked about automation, which was the first part of a two-part series. We just finished recording the second part of that, and we'll talk about that next week on testing automation. But in this episode, we'll focus on automation questions around the build and deployment process. Had a good conversation with Dave Rizzo, Vice President of our labs. And it was the second time that we'd had Dave on the podcast, and he just does a wonderful job. He's done so many good things for Compuware and for our clients. And it's just been outstanding. For today, if you want to ask a question in the WebEx, you can go. There's a little blue icon, chat icon. You'll need to press that chat icon, and then from there, you'll be able to ask your question. And then I will do my best to respond to that today. Let's see, what else from my list of things I need to make sure I get done? I think that's it. So there's a couple things I want to talk about. So let me share my screen. There we go. I want to review a couple things with regard to test data management. Those of you who may have heard me speak in the past know how important this topic is. I think it is maybe, if not the most critical, one of the most critical pieces of work that an organization has to do in order to take advantage of modern software delivery. I think test data management should be a system in and of itself. The ability to manage test data at multiple stages through that software delivery lifecycle is critically important in regards to the velocity at which you can produce software and deliver that to your customers, your employees, your business partners. Being able to properly test and to be able to do it fast, I think requires test data management. And test data management has different meanings. I think it's different things to different organizations, but essentially it's a system of capabilities to produce, provision, and manage test data. And there are varying degrees at which you can manage that test data. Leading organizations with regard to software delivery manage test data at a release level, where there is referential integrity between the test data being used and the release of the software that they're actually managing. And so there's that. I think that's part of test data, but there's also the creation, the management of the test data. It's slightly different on the mainframe, conceptually not that much, but test data management is a way to seriously control the cost associated with test data creation and test data provisioning. We spend a lot of money, especially on the mainframe, in setting up, standing up, provisioning test data. And unfortunately, it's a situation where we continue to do the same work over and over again. We've got to get better at being able to reuse, leverage existing test data, and that's going to do several things. Most importantly, if you're in an automated software delivery environment, the time you have to stand up and to do your testing is going to be limited. And in order to do proper testing, we've got to get faster at those steps. So getting faster will improve our velocity, but it'll also control our costs. And there are ways to do that. And Irene and Kevin talked about those. I hope you had a chance to listen to them. Test data management is also a way to reduce test execution runtime expenses by using the right data. And we talked a lot about that in the podcast. Using the right data means, right now it's relatively easy, and I suspect most of us in the past and currently leverage production data for our testing, again, at all stages. Now, again, from a compliance standpoint, from a regulation standpoint, we've got to mask that data. We've got to prep that data to make sure that we're in compliance with regulations regarding privacy. And so that's important. But we still typically leverage production data to do the testing work that we do. Unfortunately, we don't do a good job, or we don't spend the time necessary to right-size that data so that we can be more efficient in the testing activities. So a good test data management system with the ability to use the right data will improve our efficiency, will help us control cost. And again, I talked about data privacy. A good test data management system will have the capabilities to ensure that as an organization, you are in compliance with any privacy restrictions and regulations that you will have to adhere to. So a good test data management system will help you with all those things. Primary purpose of that, though, is to be able to provision very quickly test data needed through multiple stages of SDLC, and to ensure that compliance requirements are being met. Last week we talked about automation and its role, and automation is a part of that entire software delivery lifecycle. For me, it actually begins on the front end of a change in impact analysis. I think that there are multiple opportunities to improve or reduce the time required in that SDLC that's allocated to evaluating, assessing existing code to determine where change has to occur. And there are tools that can help that. We provide a tool called program analysis that can substantially reduce the amount of time required to determine what changes or where changes have to occur with certain requirements that are being asked of our developers. So you can automate even a lot of that impact analysis work on the front end of that change. And then obviously on the back end of that change, being able to support a continuous integration, continuous delivery environment, we can automate almost all of that work, if not all of that work, depending upon the architecture of the application. Being able to automate testing, automate deployment, automate performance testing, and certainly unit and functional testing. All of that work can be automated, and it will have a tremendous impact, not only on the velocity or the time required to execute that work, but on the quality of what you're producing. The ability to reuse test cases, the ability to reuse systems for build and deployment activities is going to do nothing but improve the quality of what you produce. And so we've got to start to look at all the work within that software delivery lifecycle and start making determinations and assessments of where we can leverage automation instead of executing that work by manual means. So something that's just going to make such a big difference with regard to software delivery. And again, it's not just a productivity issue, it's a quality issue. So let me drop out or stop sharing my screen. I'll get back to answering questions. So again, if you've got questions, please open the chat box, and you can submit your questions in the chat window. Again, we're going to, based on the best question, we'll be providing a good coding mug to you for the best question. I get to choose who that is. So get your questions in. And we've got, let's see, we've got 6 or 7 already in the system. So let me go ahead and start First question is from Ashley, and Ashley asks, what is the best way to produce test data in a modern DevOps ecosystem? Great question. The production of data really is not that different, whether you're using modern techniques or traditional techniques. There are some differences with regard to what we use. But getting test data, especially for the mainframe, I think that organizations are going to continuously or will continue to leverage production data as long as it's properly prepped. That means being masked and all the work that's required to maintain privacy requirements against that data. But it's still, a lot of people will say no, but it's still, I think, the fastest way to create test data, again, at all stages of that software delivery lifecycle. I do think what we've got to get better at is being able to cut down on the size of that data. I mean, if we're just doing image dumps of existing data, obviously some of that data is going to be huge. And the larger that is, the more time it's going to take to do the testing, especially if you're doing traditional, what I call black box type testing. So being able to select the right data and to keeping that data to as small a segment as makes sense and as gives you the ability to properly test, I think is the critical piece of work that we've got to get better at. And there are tools. In our file technologies, there are tools to help you with the extraction of data and to maintain referential integrity of that data. And that means from a physical standpoint within, say, a DB2 table, as well as from a logical perspective. If you've got the data in DB2 and you may have associated data in VSAM files or QSAM files or whatever, the ability to extract that data and to pull or to extract the proper associated data from these other data sources to build your test bed is absolutely critical. There are tools in the marketplace that can help you do that. And so I think that that's important. One of the things that we leverage within our shops is code coverage counts, being able to look at the code that we're testing and making sure that the test cases that we are using are exercising all the code or as much of the code as is necessary. We actually have produced quality gates within Sonar to help us look at our code coverage counts once a test is being executed to ensure that we're properly exercising all of the code that needs to be exercised in that code base. And those are incredibly useful metrics in the creation and in the maintenance of the test bed for a targeted or particular application. So there's some work involved in establishing these test beds and establishing the right data. But the production of that data, I think leveraging production resources, as long as it's masked and privacy restrictions are adhered to, is still the right way and a good source to produce that data. We just got to get better at sizing it and provisioning it at execution or at runtime from a testing standpoint. And I think having a good test data management system in place will provide you the ability to do that. So next question is from Matthew. Matthew asks, is producing test data for an agile DevOps environment any different than for traditional waterfall development projects? And we kind of just talked about that, answered that, Matthew. It's really, it's no different. Again, the key is right sizing, getting the right data, making sure that the data you have or are using is exercising the code properly. We want to make sure that we've got the right data to ensure that testing is complete, that testing is accurate and producing the results that we need to ensure quality code. So again, producing, I don't see a lot of difference in the producing or the production of that data. It's going to come from essentially the same source, especially if you're looking at mainframe systems. Typically, the key will be right sizing and getting the right data, because right sizing that test data will improve your velocity as you move code through your software delivery system. And so I think that's the primary key. Next question comes from Jeff. Jeff asks, how do you provision test data automatically in an app build workflow? That's a good question, if I understand, Jeff, what you're asking. I think a lot of the automated build pipes, whether it be from Jenkins or Bamboo or whatever, it really doesn't matter. Organizations need the ability to refresh or to re-provision test data every time a test is executed, and certainly you have the ability to do that work, that provisioning work, standing up that database environment in an automated workflow. And there are several ways to do that. We've got tools in our toolbox that, from a mainframe standpoint, that you can leverage. Our file aid products are all can be leveraged capabilities, the extraction capabilities, a lot of capabilities that are part of those file aid products can be leveraged in a pipeline in multiple ways. If what I like to tell clients, if you can execute a query or execute some type of report or some task that needs to be done from a batch standpoint, you have the ability to initiate that from a workflow engine. We've got, from a Jenkins standpoint, we've got plugins as part of our Topaz product that will allow you to initiate JCL from a Jenkins pipe. And so a lot of the technologies, and we've talked about this in our toolbox, are accessible through plugins, but again, anything that can be executed via JCL can also be initiated from that pipe, which essentially allows your organization to execute almost all of the work that you do in that software delivery lifecycle can be automated in that pipe. And so the extraction of data, the copying of that data, provisioning of that data, manipulation of that data, all can be executed from within a Jenkins pipeline, or quite honestly, any other pipeline, as long as there is, as long as there's the ability to execute a RESTful API from within that pipe, which essentially all CI/CD engines provide these days. So I hope that answers your question, Jeff. From Alex, in the mainframe world, how do you define a build? That's a great question. We talked about that last week with Dave Rizzo. And a build can mean different things. Typically, a build from a non-mainframe standpoint is a term used to describe a script or process that takes your code, does any necessary compiles or link edits from a mainframe standpoint to build an executable binary. And so again, depending on the language, depending on the technology, that build will may have different components in it. It may also have additional capabilities that are part of that script, like unit testing. Most modern builds, especially on the non-mainframe side, and for some time, have included additional work to ensure the quality of that code, not only the compilation of that code, but compilation and maybe some subsequent testing. Unit testing is part of that build process to produce and even deploy the executables to wherever that next stage might be, whether it be another phase of testing or even to a production environment. But that build typically represents the work required to produce an executable. In a mainframe world, we can do the same thing now. That's the beauty of automation and the beauty of being able to do the work that's been done off the mainframe for mainframe code, leveraging the same capabilities. So within a Jenkins pipe or Bamboo pipe or Ansible or whatever, I have the ability to execute, compile, link edits, testing at a virtualized testing, non-virtualized testing, at a unit level, at a functional level, at even a regression, and at a performance level. All of that type of work can be initiated as part of a build script. Now, what I've told companies in the past, and the way I like to do this, is that you define those scripts and you do it in an incremental fashion. I tell people that your first script should be a simple, compile, to make sure that that's working properly. And then as you gain more confidence, as you learn more about how that process works and how that technology works, then you start to incrementally add additional capabilities to your build. And you can essentially automate as much as you want, again, depending upon the architecture of the application and the abilities that you have. But that mainframe build is the same as a non-mainframe build. It's just the work required to produce an executable. And there are lots of steps that can be included and made as part of that build process. My belief is that you automate as much as you can. And there are organizations that will have multiple pipes based on separation of duties or compliance requirements that require different people to execute on that work. I work with a few banks, and typically there's some separation of responsibilities, duties within that, where certain people can only do certain things within the SDLC. That's fine. Typically, there are multiple pipes that can support that software delivery lifecycle. You may have a pipe that's used to support the commit or the development work for a developer that they're leveraging to do their unit testing prior to giving an okay to be moved to QA or to testers within your Agile team. Testers may have their own pipes that are more focused around integration testing work, functional testing work, regression testing work that they typically are responsible for before being transitioned maybe to another group that may have their own pipes for production deployment. You can set these up, in a way that makes sense for your organization based on requirements, policy of your particular organization and how it delivers software. But that build process is conceptually the same thing, regardless of target. It's the ability to take code and to deliver it in an executable format. Okay, next question is from Sam. Sam asks, are the mainframe code compile and link edit steps executed off the mainframe from within a Jenkins job? So if I think if I understand your question, Sam, are you saying or I think you're saying, is that compile work and link edit work actually done off the mainframe? No, that work should be executed on the mainframe. Now, it can be initiated from a pipe that's working wherever your CI/CD engine is running. So if I've got a Jenkins pipe running on a Windows machine or a Linux machine, and I want to compile a COBOL program that's targeted for the mainframe, then in our scenario with our tools, you can initiate a RESTful API request to our build engine, which is ISPW, to do that compile or generate link edit for you. You can subsequently, if that compile and link edit works properly, you can execute additional testing functions, again, from your CI/CD engine, regardless of where it's running. that work is going to be executed on the mainframe. It's where it should be executed. So hope that answers your question about that. We've made it easy to do that work, especially in Jenkins, because we've got plugins to initiate all of those different steps that you can leverage, where it's simply plugging in the parameters within the plugin to handle that communication between the CI/CD engine running wherever and to the mainframe for execution of that work there. That's where it occurs. Okay, next question is from Liam. Can you execute mainframe JCL from a Jenkins pipeline? Yes, you can. We talked about that briefly earlier. There's a part of our Topaz CLI. Again, within Jenkins, we've already got plugins and RESTful APIs that will allow you to submit a JCL member or a set of members within a PDS or within ISPW that will allow you to execute that JCL or submit that JCL to your initiators for subsequent execution. Now that's really important, because if you look at tools like HyperStation, which handle regression type testing, the ability, and we can those test cases can be initiated in a batch mode, regardless of whether they're online or batch. The ability to initiate that work from a Jenkins pipe is easily done through the execution or initiation of that plugin or that RESTful API to do that work from your CI/CD engine. So, and that's a very, very useful tool. We use it a lot in our own organization for a lot of our testing. We've got multiple products that go through multiple testing phases and multiple releases. And for a lot of the mainframe components that we're providing, we use HyperStation to do a lot of the regression testing that has to occur on that code prior to delivery to a production state. And we use the ability to initiate JCL from our CI/CD engine. Again, ours, we use Jenkins to do that work, and it works very, very well. So there are multiple ways to do that. If you've got a service that can be initiated through a RESTful API request, like our ISPW services and our total test services, those can be initiated that way. But if you've got other services that are executed traditionally through JCL, you can execute those jobs as well, and you can initiate it from an automated pipeline. So let's see. Hopefully that answers that question. And let's see, I've got one more from Noah. Noah asked, automated deployment on the mainframe has been around for many years. What's the difference now? That's a great question. I remember being at IBM years ago and hearing all the talk about automated deployment for mainframe applications, mainframe code, load modules, and thinking, what's the big deal? Automated deployment had been around for 30 years. We were doing automated deployments for load modules, mainframe code, through our SCM, our source control management systems, back in the 80s. And so, I didn't know what all the hubbub was until I started to think about it. And the differences and why it's important today is the architecture of the applications. Back 30 years ago, we were building applications that were siloed, quite honestly, that were targeted to a specific platform. We were building mainframe applications that ran on the mainframe. We were building other applications, or starting to build other applications that were targeted to another platform, whether it be a web server or mobile when that came around, or non-risk-based machines, wherever. But the applications were typically siloed. And we began to integrate those systems a few years back, but most of that integration actually occurred from a file standpoint. For the last 10, 15, maybe even 20 years now, there's much more integration in these components that define an application. So you may have an application, a retail banking application that has a mobile component, you have a database component running on a risk-based machine, and it's very likely that it has a mainframe component. Well, those components need to be synchronized from a deployment standpoint, because there may be dependencies on release levels within components that are spread across multiple platforms. And so automated deployment today has a much different meaning than it did 30 years ago when we were automating deployment through ISPW or Endeavor or Librarian or Pambalay, whatever, than it does today. Today, we've got to make sure that all the components that comprise that application can be synced and managed at a release level. And so tools to provide release management capabilities and deployment capabilities can ensure that that synchronization occurs in the delivery of applications that reside on multiple components. So it's even more important today, even more important than the delivery of that code to a production state is the ability to recover when there are issues within that code. And so having automated deployment and release management systems to provide support for that is absolutely critical in a modern software delivery world. But again, that's because of the application architecture and its requirements to manage components across multiple platforms. So hopefully that answers that question. I do not see any more. So again, I appreciate you coming to the live Q&A today. I appreciate your time. If you've got questions, if you seek or would like additional information about the many different podcast topics now that we've talked about, you can go to compuware.com/goodcoding. We've got all the podcasts, all the live Q&As, I think are available there. You can download those. And again, if you go through that and you've got questions, you can send me an email, rick.slade@compuware.com. I'll be glad to address those questions there, but you can also continue to come to our live Q&As and raise your questions there. So thank you again for your time. We appreciate it. We hope that this has been educational and helpful in your journey as you begin or as you are in the throes of evolving or changing how you deliver software to the market. Hopefully it's you're doing that work and you're starting to see results. So we'll close out today. Again, thank you. We appreciate it. Good luck. Have a great week, a safe week, a good weekend for those of you who are seeing this on Friday. Take care, everybody, and good coding. Take care.